Hi, my name is Willie, and today we're going over ignition. Everything ignition. Okay? And we're going to start off with the basics with the coil timing. This is going to be a long video, so hopefully you guys will stick around and enjoy. Okay, now, as for ignition coils for these cast iron Briggs, with the starter generator style, the OEM coil number was 298968. That's discontinued from Briggs, but you can get aftermarket. You can cross-reference this part number looking online for a coil. And this will be the part number for an electronic ignition, which I will be swapping to in this video. We'll be going over that. Okay, so that being said, we're going to talk coil timing. Now this engine is going to be used for tractor pulls, so it's going to be used for sport, and I want to get a good advantage of ignition timing because I'm running a higher octane fuel, like 93 or 100 octane, different things like that. So I already went back and put some timing marks on here and put a nice white marker here to see where my degrees are at. I'll go over that later. But as for OEM timing, you take this arrow and put it at the end of the leg. It's usually straight up and down. It's the factory timing. And the magnet will be just after the leg here. Let me see if I can't get better light in there. So the end of the magnet is right here. And there's a little bit of aluminum between to that other leg. And this arrow is in line with the outside leg here. Okay? So when you time that, that's the factory position for this coil. This coil can move side to side. As for the air gap here, you want to use something that's about 1/1000th of an inch. Okay? So anything, whether it's... Let me get the camera set up for a second. Now, as I was saying, anything can be used to set the coil gap. It's minimum of 10/1000ths. So it could be sandpaper. We got 10/1000ths, but in this case it's about 12. You have a folded over piece of plastic, and that's about 17/1000ths, 18/1000ths. You have a piece of aluminum. It's about 20/1000ths. And this coil came with a piece of plastic in here to gap it, if I can get it out of there. This is like a piece of plastic here, and this is about 1/1000th of an 10/1000ths also. So as long as it's between 10/1000ths and 15/1000ths air gap, you should be good. Follow the instructions as usual. And I always like to use a feeler gauge to check my gap. You gotta go right underneath the magnet, right here, the thousandths. You want at least a 10/1000ths gap underneath there. So you always want to double check your work. Now the reason I was getting into this as well is the original coil had grounded up against the flywheel. There's a shiny spot there and a shiny spot there. So this wound up getting overheated and shorted out. So it was getting very erratic spark. So it'd be bright, it would be dim, it would just, and then it wouldn't work, and then it'd have one spark and then no spark. So I had to replace this coil. This is a standard coil still running to the pointing condenser. Okay, that's still hooked up. So I want to show you how easy this thing sparks quick. So now we have that lined up here, and the gap set correctly. Now the next issue is going to be the points. The points have to be isolated to time them correctly. I'm going to use a multimeter to time them. We're not worried about so much of the gap so much as when they open. Okay? So I'm going to unhook this wire and I'll turn the camera back on. So hang on. Okay, I got my meter set to continuity test. This will beep when I have continuity. Now my points are isolated. And here we have continuity between the points. We lose continuity here. We want the points to be open when this arrow is with this leg. So you hear that's open. So that's closed points. And that's when they're open right there. Okay? So this not only lines up with your coil, it also tells you exactly when to time your points to the end of this leg or where this magnet just leaves this leg. Okay? Now let me hook up my test light, or I'm sorry, my timing light, and we'll see what the degrees before top dead center this is quick, and then I'll go into a good description as to how to find your top dead center. Okay, so hang on. Okay, I'm not sure how good you guys are going to see this, but I'm going to try and get this with the timing light. Okay. Okay, we're firing about right here, about 28 degrees or so. Now I'm going to get into advancing the spark, having the spark come up earlier, and see how close we can get to this red mark, which would be 30 degrees. Moving these things around, see if we don't have the travel in the points. Now I got the flywheel off. You'll see how there's some room for timing this direction, which would retard it. And then there's room over here to advance it. I'll get you a little closer. These bolts are in slots. See, that would retard to go this direction, to move the coil to the right. And I'm sorry. Yeah, if you move the coil to the right, you retard it. If you move the coil to your left, you're advancing it. So there's room here and here to move the coil in either direction. So what we're going to do is we're going to advance it, okay? See how far we can go. Okay, now we have a coil as far to the left as we can go, and that's going to advance our spark. I loosen the two bolts up here for the coil, move the coil up so it doesn't bind up on the flywheel when I go to put the flywheel back on. Make sure you check your torque specs on your flywheel, and I will go into more detail when we start getting to the electronic ignition about this tapered shaft, as well as the advantages and disadvantages to timing, okay? So let me get the flywheel back on and we'll get back to setting the points. Okay. Once again, we have this magnet on this side, just barely leaving the inside part of that leg. Should be able to see the arrow on the end of the coil over here. See, that's the points closed, and that's points open. Just as the magnet leaves this leg. Okay? So we got the points timed once again. And if we look at the diagram here, or I'm sorry, the timing marks, the black line is the 30 degrees, so we have 0 at top dead center, 5, 10, 15, 20, 25, and 30, and then the red mark is where I'm hoping to get to. Okay, I want to get about 31, 32 degrees out of this. And I'm only going to be running high octane fuel through this engine. Okay, so let me get my timing light on. We'll see where we're at in timing. Okay, now I'll talk a little bit right now quick. I'll touch base. I'll talk about it again later. But we want to advance our spark. Now, some engines will run 15 degrees before top dead center. This one's probably happiest around 25, 27, 28 degrees before top dead center. Now, if you're running a higher octane fuel, you can run 32 degrees if you're running a good 100 octane fuel. If you're going to run regular, I would suggest staying right around the 25 mark. If you're going to run regular fuel, anywhere from 15 to 25 degrees before top dead center would be good if you're running just cheaper regular. That way you don't get pre-ignition. This is a flathead, so it takes a while for the flame to fill up the cylinder, so it doesn't hurt to have the extra timing on this. you have an overhead valve, they might be a little more sensitive on timing than the flatheads. So it's just a word of caution. Not to mention the flatheads don't tend to run as high of a compression as the overhead valve engines in some cases. Okay, so there's your caution here. So we're going to see where this is at. Hang on. Okay, now that we've advanced this coil so far, that even though the points are timed correctly, the time in which the coil is being passed by the magnet and the points are just barely starting to close, the magnetic field isn't generating and collapsing at the proper timing because we're so far advanced that the points aren't closing long enough for enough of a magnetic field to generate in the short period of time they are closed. So now I'm not getting the spark at all because the timing on the cam for the points to close is not adjustable, which is another reason why you gotta go by factory, which is another 5 degrees or so later. So we're gonna have to put this coil back to where it was, where it's all straight up and down, and retime it. So I cannot get the 30 degrees like I'm aiming for out of the points condenser, because then the dwell time isn't correct for the points and the primary coils to generate the high voltage. So now what I'm going to do is I'm going to start going over swapping this coil out, the points magneto, with electronic ignition magneto, which I'm going to pull over right now, okay? So hang on. Okay, now for the good stuff. This is the electronic ignition. It's going to be replacing the points condenser. Part number is 398811. This comes with the coil, which is right here, the kill wire. You have an option of using either the eyelet or the copper. I'm going to cut off this wire and leave this one, just run this down to the post that goes to the points cover. In my case, I had to mount it with the cylinder side out for some reason. I don't know. That's just how this worked. If I turn around the other direction, it doesn't get spark. This direction, it does have spark. I also have the timing where I want it. I don't have to move this post anymore. So make sure you follow the instructions on that. So, as for my points, I just close the gap all the way so the points aren't moving or opening and closing, but the plunger is still in the hole blocking the oil, because I can't take the plunger out because it's in 2 pieces, I believe, in this block. So I can't take the points plunger out and plug up the hole. So I just turn the points all the way out so they're not moving. So I'll just leave these points in. I'll just put the cover back on. So right now I'm going to set you guys up with the timing light and we'll see what we have in timing. Okay, so didn't have to move this post. Oh, quick word on how these work. Okay. Now the points and condensers have the points closed when the magnet's half past this first leg. The points would be closed, and then just before this leg leaves, the points would be open, and then the spark would go off. Okay, with these, usually there's 3 poles, I believe, on this magnet. The current will go back and forth, back and forth, back and forth. It's usually just when the leading edge of this magnet goes to the end of this, somewhere around here, while this end of this magnet is underneath this leg, it sparks. It doesn't spark after like the points condenser does. It sparks somewhere a little bit before, because it runs a little bit differently. So let me get you guys set up. Okay, let me get these lights all off. Okay, let me rewind that and double check. Okay, we're sparking just a little bit after that red mark, so right around there, which is right about 32 degrees, which is what I wanted. So I got my spark all straightened out. So that's good. Yay! I'm excited. There you have it. Electronic ignition on a Briggs. Don't have to change anything. Just gotta have the right part numbers. So, this is a coil to fit this application for points of condenser. Okay. Now, one thing some people do is they'll buy these electronic ignitions for the later year cast iron Briggs, which have this button. This button will not work with these older star generator style flywheels. So that's just a word of caution for you. These are not going to work on here. You have to have the correct coil on here, which, like I said, the number was 398811. Okay? The electronic ignition that'll fit this star generator type flywheel. You don't have to send the flywheel out to be repolarized, and you don't need to hook up your points condenser. You will have to hook up the kill wire a little bit differently, but you don't want to hook that to points and condenser. Okay? So now that I got my ignition where I want it, now I'll go a little more over degreeing your engine. Now, this can be a little bit tricky. What you're going to want to do is you got to be able to know, you have to come up with a set point to set your piston and come up to top dead center. So in my case, I'm sticking a screwdriver in here. In such a way, going to have the blade flat. So that usually goes in there pretty good like that, and I will turn the piston up till it just barely touches that screwdriver. Like so. I'm going to crank this over. We'll see if that moves. Oh, there it goes. Just moved. Now, this should be around 60 because I had already set it. I bolted a wire here to the engine to time it, so we're at 60 here. Now I'll turn it the other direction. Come up on top dead center. Alright, hit it. So right there. And that should be 60 degrees once again. So that's 60. Now if you're off, if it's 70 on one side and 55 on the other, you just add the two together and divide by 2, and then you want to center this up. So you want 60, in this case we're going to have 60 on both sides. So since we're having the same number reading both directions on this flywheel before the screwdriver starts to move, when the piston reaches a certain point, then we can take the screwdriver out and know that this is our absolute 0 for the engine. So once I had that all written down, I painted the flywheel white, and I made this piece of bent this piece of metal from a piece of aluminum and cut it in somewhat of an arrow shape. See, that's my absolute 0 right there. So what I did is I turned the flywheel to an X amount of degrees, and I'd come over here and then I'd mark it and then go another 5 degrees, going by this, and then come over here and marking it until I got to about 35 degrees, and then that would be 20 degrees. I put the red marks because that's where I want to get it to. Okay? So there's your quick tip on degreeing that. Now, if you want to get earlier ignition for performance out of these things, and your coil does not move, then you can look up, what is it? ARC Racing, and they have a video on taking the flywheel keys out of an engine and hitting the tapered shaft with some grinding compound, like valve seat grinding compound on the taper, and then you run the flywheel back and forth, and you wipe it off, and you put a little bit more on there, and then you rotate the flywheel on the shaft a few times to the point where the tapered shaft and the flywheel are mated. Then you can set your timing wherever it is you want it. He also talks about where to set the legs on the coils and even the gap. So you don't need the flywheel key is just to help you time it when you put it together quick, but you don't necessarily need that key when you have a tapered shaft to hold the flywheel in place. Generators don't have keys, is a good case in point. Okay, since this ignition is where I want it, and I just have to move this coil over and put an electronic ignition on there, I'm good to go. Yeah, I'll be sure to put that video in the description down below, as well as the part numbers for the coil from an Amazon, for those of you looking for a coil. And even a word of caution to not buy the electronic ignition for this type of engine as well. Okay? Yeah, this won't work on this engine. I'll just put this number in there anyway for those of you that might be looking for it, but there it is. Everything spark and timing you could ever need to know about your cast iron Briggs engines. If you have any questions, feel free to ask in the comment section, and I'm going to wish you to have a good day. Bye.